Hey, good morning, everyone. Happy Tuesday, and thanks for joining our electrical safety panel discussion today, hosted by Grace Engineered Products. We have three panelists today, Terry Becker, Charles Miller, and John Kolak. I would like all the panelists to just introduce themselves and what they do, so that gives you a good context on their standpoint on electrical safety and how it relates to them. And then I'll be moderating this webinar today. My name is Banu Srila. I work as Director of Technical Marketing with Grace Engineered Products. So quick disclaimer here, the responses to the questions and the views and opinions expressed during this webinar, electrical safety panel discussion, are those of the speakers based on their professional level and personal capacity and does not reflect the position of the organizations or other committees they represent. The recommendations and any suggestions provided during this webinar session are purely for informational purposes only and cannot be used in real-world applications without a detailed analysis and written authorization and consent from the presenters. Okay, so by participating in this discussion, the attendees consent to waive all the liabilities arising from the use of the information presented and any misuse of the information that could result in the personal injury, property damage, or any other negative consequences on the presenters and the organizations they present. Okay, so additional information here, the questions submitted along with the registrations will be answered first because we had about 322 registrations for this safety panel discussion, and we had about 90 questions so far, and we'll answer that in the sequence it's been provided in the prioritization. And also, please submit your questions using the webinar console. You can see it on the dashboard during the webinar as you have any follow-up questions, and we'll answer them as the time permits. And last 2 points, basically, the attendance of this event will qualify you for receiving the CEU certificates for attendance, which you can download it after the event. And please do remember to take the exit survey and provide your feedback at the end. So without further delay, I would like the panelists to just quickly introduce themselves. Terry, go ahead, please.
Thanks, Banu. Hey, welcome to the webinar today. My name is Terry Becker. I reside in Calgary, Alberta, Canada. I'm an electrical engineer. I provide electrical safety consulting across Canada in the interpretation of CSA Z462 Workplace Electrical Safety Standard, which is technically harmonized with NFPA 70E. So I perform audits, electrical safety program development and training, and I'm really glad to be online for this Grace webinar today.
Thank you, Terry. John, please go ahead, John.
Hey, good morning, everyone. I'm John Kolak. I'm the president of Praxis Corporation. My background is I'm a journeyman lineman. I'm also an electrical engineer and a certified safety professional, and I do mostly arc flash type studies for the engineering side and a lot of electrical safety training as well. And I'm grateful to have the opportunity to work with you all.
Thank you, John. Charlie, please go ahead.
Good morning. I'm Charles Miller. I live right outside of Nashville, Tennessee. I write electrical books and used to write magazine articles. In Electrical Contractor magazine, the column called The Code in Focus is one that I have written. I wrote and illustrated for 19 years, but I write and update electrical books. The recent one that it was quite an honor to be asked to update is the Uglies Electrical Reference that has been out forever. And that I actually had that book when I was an apprentice in 1978 or so. I also teach electrical seminars, custom seminars, electrical and electrical safety.
And in addition to that, Charlie also sits in the NFPA 70E technical committee, right? So he has all the knowledge about the safety committee information that's relevant, okay? So thank you, gentlemen. Thanks for joining the safety panel today again. We really thank you so much for taking your time, of your valuable time from your schedules and getting this. All right, so we'll go to the first question. So this is for Terry. Terry, the question is, can you explain arc flash PPE requirements when first opening an electrical panel to verify the lockout?
So I guess if I have to look at, again, I mentioned NFPA 70 and Z462 are technically harmonized. So when I talk in generalities, it would apply to Canada or the US. So the first thing here is to understand what the work task is, and if the work task is opening a hinge door, then that is an identified work task in table 135.c or table 2 in Z462. And if you look at that table, depending on condition of maintenance, it does say that the likely occurrence of an arcing fault occurring is yes. So in that circumstance, you would require to complete an arc flash risk assessment to define the PPE that you would need to open the hinge door. Now, I don't necessarily agree with this one because depending on the electrical equipment, not every hinge door, in my opinion, would create an arcing fault probability. So I recommend that a risk assessment's been completed against the electrical equipment that the hinge door will be opened on. So it's sort of a loaded question because it depends, right? So if you look strictly at 7E and Z462, the table 135.c and table 2, it would say under any equipment conditions, the likely occurrence of an arcing fault is yes. Again, I've got to quantify that. I don't believe that's true for all hinge doors on all electrical equipment. So this is the interpretation part of 70E and Z462 that you've really got to look at what it says, but I think you have to do your own risk assessment. For instance, do I need arc flash PP to open up a junction box, right? It would imply that any hinge door requires arc flash PP to warn. So, or a PLC or a DCS control panel, do I need arc flash PP to open up those hinge doors? So I would beg the user to make sure that, on this particular work task, that you look at the electrical equipment that the hinge door is on and what's behind the door and the condition of maintenance, and then decide if the arcing fault is likely to occur or not.
Okay. Thanks, Terry. So the next question is, what key factors should one look for in keeping the electrical cabinets up to NFPA 70E standard?
Well, in accordance with the question, I was thinking about this, and I would reference 110.1H3, that is the hierarchy of risk control methods. And this section tells us that the risk assessment procedure has to require that preventative and protective risk control methods be implemented in accordance to the hierarchy of risk control method. In fact, that's what's on the very front of NFPA 70E, and it's in a pyramid form. I really believe that pyramid should kind of be turned upside down, but that's another story. That's another webinar. It starts out with the hierarchy of risk control methods as eliminating the hazard. And then it goes through substitution, engineering controls, awareness, administrative controls, and PPE. The first three are the most effective. The last three are the least effective. This particular question, I would think, really can be affected by number 3, engineering controls that can be built into safety with control panels and things even like that's mentioned in one of the informative annexes in the back, touch safe or finger safe. And even substitution would be an example of that, maybe changing the control wiring from 120 volts in a motor control center to dropping it down to 24 or 48 volts to make it a bit safer. But it kind of comes back to what Terry had already mentioned, which will probably be mentioned a lot today, risk assessment.
Thanks, Charlie. I mean, quick point out to that is, as Charlie mentioned, the top of the 3, like elimination, substitution, and engineering controls, these are pretty much applied at the source. And the one that below, like awareness, PPE, and the procedures, those can be influenced or affected by the human error because there's a lot of subjective measures to that, okay? So let's go to the next question. So this question is for John. Will the electrical safety standard NFPA 70E at some point deal in detail with electrochemical cells?
Yeah, and I was thinking about this question, wondering, it may be a vernacular issue with whoever posed the question, but the NFPA 70 addresses this in 2 different places. 310, Article 310 has to do with electrolytic cells, and then 320 has to do with batteries and battery rooms, which are more electrochemical type cells. So it may be that they have a specific application here that maybe that we're calling it something different. And if so, if the person has a chance to ask a follow-on question, let's have them type that in, and I'll give them a better answer. But my initial reaction would be to look at Article 310 and 320 and see if that includes the equipment that you're discussing in the question. And if not, ask again, and I'll try to give you a better answer.
Okay, thanks, John. So the next question is for Charlie. Safety by design is gaining momentum. Can we expect to see proposals to the NEC to require safety-minded equipment to be installed? Charlie.
The answer is yes. Let's move to the next question. No, I'm just kidding. All right. So, of course, the NEC, the National Electrical Code. Well, let's start out with 90.1A. What is the purpose of the code? It's very similar to the purpose of NFPA 70E. The purpose of the National Electrical Code is the practical safeguarding of persons and property from hazards that arise from using electricity. Well, the NEC already has throughout the document requirements pertaining to safety. It is a safety code. It's more for an installation code than the National Electrical Code is for the installation, whereas 70E takes over after all of the electrical conductors and equipment and systems have been installed. But I thought about a few things that are in the NEC. A big one that's been in there for a while is just arc flash warning in 110.16 in the National Electrical Code. And then in the 2017 edition, they added an A and B. It used to just have a very general statement, and then section B was added in the 2017 edition. Now, the newest edition we have out there, the 2020 code just came out about a month ago. So but very little of this changed in the 2020 edition. There is a requirement in the 2017 edition for service equipment, and it's talking about in other than dwellings, there's an additional, in addition to A, which is the general arc flash label that just has to say warning, arc flash hazard, just some general generic information. Now you have to have a permanent label, field or factory applied at service equipment rated 1200 amps or more. In that section 110.16, there are specific requirements that have to be on that label. There is an exception though, if the label is like our arc flash label that we have in accordance with 70E, that is permissible to, instead of having the other information like the available fault current and the clearing time actually on the label. There's another one that went in a couple of editions back that's talking about, and this is Article 240, overcurrent protection. Article 240 is .67 covers arc energy reduction, and what this says is where fuses rated 1200 amps or higher are installed, 240.67A or B shall apply. Now, when this went into the 2017 edition, it had a note in it that said this section becomes effective January 1st, 2020. So, and of course, it depends on cities, states, and jurisdictions when they accept particular editions of the National Electrical Code. If a city, state, or jurisdiction doesn't adopt the 2017 edition until 2021, of course, this provision is already going to be in existence at that point. If city, states, or jurisdictions have already adopted the 2017 edition, this particular arc energy reduction requirement doesn't come into play. It doesn't take effect until January 1st, this coming 2020.
Thanks, Charlie. I mean, I have a quick follow-up question on that, Charlie. I mean, I was looking at the NFPA website on the implementation or the enforcement of the NEC specifically. So they had this entire US map of the different states, and they identified like some states are still in 2011, 2013, right? So somewhere in way behind. Do you know what's the reason for that and why it is done so in that way?
Well, yeah, the National Electrical Code is a legal document that has to be accepted or brought into it has to be adopted into a city, state, or jurisdiction's requirements. And for one thing, going over the changes and updating everything is quite extensive process for these jurisdictions to do. There's also some other outlying forces that lobbying of other of maybe the building contractor industry. I know this is pretty, it plays heavy into, for example, Nashville, Tennessee. They have been pretty successful in keeping a lot of the new arc fault requirements out of the Nashville requirements. And so this is just something that it's not a requirement when a particular jurisdiction accepts this. They can do it at any time. And there are maps out there, like Banu mentioned, that go back, and there are probably places that are back to 2008, if not before.
Yeah.
So that's when I'm teaching code change seminars. It's not unusual that, for example, one of the last seminars I taught for code changes, I did, it was half on the 2014 edition, half on the 2017 edition. Well, when I put that seminar together, I actually pulled all of that information. Instead of teaching 4 hours on 2014 and 4 on 17, I compiled everything together where it flowed much smoother, where it would be easier to understand. All right, this changed in 14, but yet it changed again in 17. But yeah, that's a great question.
Thanks, Charlie. So the next question is for Terry. How do you design your lockout tagout program for service work where you run into the different equipment at various customer locations? I think it's a very good question.
Well, again, I think this one, when you read it, I'm going, well, your occupational health and safety management system and the related lockout tagout program policy is generically applied against all workplace hazards. So I'm a bit confused when there should be a difference between your lockout tagout program being applied differently at different locations for different customers. So if you look at Article 120 and NFPA 70E, it's a generic, lockout tagout content. It's what energy source are you isolating? There should be an energy isolating device, and you follow the requirements of your lockout tagout program with individual lockout or group complex lockout. So I think that your lockout tagout program is generic and it's applied against not only electrical energy but all energy sources generically. Again, individual lock and tagout. I have my own lock. I have my own tag, right? You protect yourself individually with respect to your company's lockout tagout program and what's afforded to you as the individual worker. So every customer site, you apply the lockout tagout program and policy generically. It's not something that you would customize or change. It's sort of cast in iron as far as what your employer is saying you shall do as an individual worker for, again, individual lockout, and it's not going to be different at different customer locations. So when I read that question, that's sort of the answer I come up with, is that your lockout tagout program defined by your employer, again with additional information in Article 120 and 70E, is applied the same at every client site. You're not going to compromise a policy in your lockout tagout program because a client it requires you to do something differently. It's quite clear when we look at establishing an electrically safe work condition too, that that's a generic 8-step process. You're not going to say, well, I'm not going to do steps 2, 3, and 4 because that customer doesn't want me to do that. So again, generic lockout tagout programs, policy documents by your employer applied the same at every client site. 70E provides specific content in Article 120, and I specifically point to establishing an electrically safe work condition. It's applied the same every time. Right now, depending on if it's low or high voltage electrical equipment that you're isolating, then establishing an electrically safe work condition does require some of the steps you wouldn't necessarily follow. So that's the only difference I would see. If your client has low voltage systems, then things would be different than if your client has both low and high voltage systems with respect to applying your company's lockout, tagout program and the requirements of NFPA 70E or CSA Z462 here in Canada.
So Terry, the way I look at this question is, I mean, as you mentioned, the company might have a generic lockout tagout procedure. However, if you take the different sites to consideration, will there be any way that there'll be a site-specific requirements that would imply as well, and in addition to the normal lockout tagout? You know what I mean? So I could be a huge multinational company having 7 locations in the US, varied on different states, but will there be any fine tunes to be made to the site-specific requirements based on the employee qualifications or their standard procedures or whatnot? So do you have any comments on that, John or Charlie? Or
if I can just add to that, so what you might find is that a client maybe doesn't have any lockout tagout requirements, or it's very weak, right? So you better ensure that your company's lockout tagout program meets or exceeds, and in some cases, Abano, so I think your question, the comment you just posed is I may go to a site and the client doesn't provide any direction, right, or has limited direction. So then you better ensure that as the employer working for, you know, the qualified persons doing electrical work in this case, that your lockout tagout program, you know, review Article 120 again in NFPA 70E and follow the requirements of establishing an electrically safe work condition.
Yes, John, go ahead, John.
Yeah, I would just add that the criteria to become authorized under the lockout standard requires that you're first qualified for that piece of equipment that you're working on, and then you have to take a written test, demonstrate proficiency in front of somebody who knows the difference before they actually allow you to be authorized. And so if you're authorized, by definition, you've been trained both equipment specific and task specifically to be qualified. So that lockout tagout energy control is part of what we do as for qualified workers, if your work entails that kind of thing. So the qualified worker requirements would take care of the site-specific part, because you have to be able to demonstrate proficiency on the kinds of equipment you're actually going to work on, rather than, so the generic requirements apply. The site-specific part has to do with procedurally and technically how you accomplish energy control.
Yeah. Thanks, John. Thanks, Terry. That's a detailed question. So the next question is for Charlie. Do all electrical panels require an arc flash label?
No. Next question. That didn't work a while ago, so let me. All right. Let's look at. We're talking about National Electrical Code. We're also talking about NFPA 70E. In the National Electrical Code, section 110.16a is what you want to look at. 110.16a. This says, and it's very similar. It's almost identical to 70E's 130.5H. 130.5H. The NEC says electrical equipment such as, and now it's not an all-inclusive list. It gives us an idea what would be included. It says such as switchboards, switchgear, panel boards, industrial control panels, meter socket enclosures, and motor control centers that are in other than dwelling units. Of course, this does not apply to dwellings. And here's the key part. It's likely to require examination, adjustment, servicing, or maintenance while energized. It shall be field or factory marked. The factory part was added a couple of editions, now a couple of editions back. It used to say it had to be field marked. Well, what this is saying in 110.16a, mentioned this earlier, this is the general statement, the general rule, just the general arc flash label. And it's field or factory marked to warn qualified persons of potential electrical arc flash hazards. In 70E, it's almost identical for the first several lines. Equipment such as switchboards, panel boards, industrial control panels, meter socket enclosures, motor control centers that are in other than dwelling units. It's all the same, except switchgear is not, it wasn't in 130.5H and at this point. And it says in other than dwelling units, and that is likely to require examination, adjustment, servicing, or maintenance while energized. have to be marked with a label containing the information in 130.5 H1 through 3. And then that gives us more detailed information that has to be on the label in 70E. And so it comes down to, is the equipment likely to require examination, adjustment, servicing, or maintenance while it's energized? All right, let's think of maybe a 25 kVA dry type transformer. And we'll say, okay, do I have to put a label on that? Well, are you likely to examine it, adjust it, service it, or maintain it while it's energized? With this particular piece of equipment, I can argue both sides. I can say, no, I'm never going to be in that equipment while it's energized. I'm always going to de-energize it if I ever open that front panel up. And say, and I could almost argue the other way around, saying, you know, sometime, whether it's when you first install it or some point, you're probably going to have that open and do voltage testing. Well, no, I can do voltage testing from the disconnector panel board where the conductors land. So it really comes down to, you've got to determine, are you likely to require are you likely to examine it, adjust it, service, or maintain it while it's energized? There are companies out there that yes, they when they do the labeling, they put them on all 120, 208, 277, 480 volt panels. I was at a particular company, for whatever reason, that they didn't have labels on the 120, 208 volt panels. I was doing an arc flash gap assessment for that company, and that's one of the things that I noted, is that I referenced this section because those 120, 208 volt panels, in my opinion, are likely to require examination, servicing, maintenance, or adjustment while it's energized. So in my opinion, those 120 volt panels needed labels as well.
John, do you have anything to add, John?
Well, no, actually, I absolutely agree with Charles in his perspective. What I would also say, I'm a journeyman, so I prefer that you label things, even if it's not likely that I'm going to address them, because if I'm going to go in there, I want to know how bad it is, and I get to decide. That's why I get to be a journeyman. So I would rather have the thing labeled when it's questionable if it applies or not. Let me decide what I'm going to do about that as a journeyman.
Thank you.
And can I just add that in Canada, we adopted Article 110.16 into the Canadian Electrical Code as Rule 2-306. So it's very similar. That label was added in the 2006 Canadian Electrical Code, requiring a minimum shock and arc flash label. So we actually said that it has to say shock and arc flash and a minimum label requirement. And then after that, you would, as Charles was talking about, follow the requirements of CSA Z462 again, which has the identical equipment labeling requirement. And in general, I agree with all the comments that were made.
Thanks, Terry. So the next question is for Terry. What level of preventative maintenance or inspection should be done annually on electrical equipment? This is a loaded question, Terry.
These questions are loaded because you could talk about any one of them for quite a bit of time, actually. So that's the challenge here. So I got to go backwards a little bit on this, that, you know, when we look at electrical equipment maintenance requirements, 70E and Z462 and their latest additions with risk assessment has placed more emphasis on condition of maintenance. Table 135.C and CSA Z462's Table 2, which is under the arc flash risk assessment requirement, as I already mentioned, requires that you look at the work task, you look at condition of maintenance, and then decide on the likely occurrence of an arcing fault in arc flash as yes or no. And it's any equipment condition, normal or abnormal. So the condition of maintenance has now come up as a subjective, well, how do I know the condition of maintenance? This question says what level of maintenance should be done annually on electrical equipment. So what I'm going to offer is that you have to, again, use this concept of risk assessment, right? Again, it's a very common theme, and risk assessment's a pretty powerful tool. So what we did is, in Canada, we created our own electrical maintenance of electrical systems guideline back in 2013. It's called CSA Z463, right? So we now have the equivalent of of NFPA 70B, right? In Canada, it's not the same. They're different, right? But the concepts are the same. 70B is a lot more detailed. So again, loaded question. Again, you need to look at the equipment you have. You should have an asset list and define the maintenance by safety and criticality of service. And then you have to look at what specific test you want to perform. You know, what strategies do you want to deploy, run to fail, PM, PD, RCM. So, you know, not to overcomplicate the answer, but you're right. It's a loaded question. It's not as simple as, well, you know, Harry says we should do annual maintenance on our circuit breakers because, you know, that's his experience. Well, that might be my experience, but I always recommend now that we look to the applicable industry standards for electrical equipment maintenance for Canada, CSA Z463, and for the US, NFPA 70B. Plus, we also have the ANSI NETA MTS standard, which provides specific information on specific tests, but also has the content to determine frequency of different types of electrical tests. All three of these standards would assist industry in North America because they're all slightly different and they all have, you know, valuable information. So for the US, 70B ANSI NETA MTS would help you in defining the tests that you should perform and give you some guidance on frequency of those tests being performed. So it could be annual, it could be every 3 years, it could be every 5 years. It again depends on your risk assessment. So I think we should be doing risk assessments for maintenance requirements around safety and then, you know, reliability and you know, criticality of service to the process. So again, not a simple answer to that question, but there's some guidance in these maintenance standards that are out there, and I encourage industry in Canada and US to get your hands on these maintenance of electrical equipment standards and apply them accordingly to your facility.
Thanks, Ray. But I have a follow-up question from the application standpoint, though. So this is more like when we go and talk to the maintenance folks, they say, okay, these standards are fantastic. It's well defined on 70B, Z463, everything is clearly defined what needs to be done. But justifying the time to perform that maintenance is becoming increasingly difficult because they say this equipment needs to be running 24/7. I don't have time to shut it down, right? So I would rather shut it down. Nothing is broken, so why would I even fix it? So that's kind of the discussions they're getting into because they don't know what's wrong, right?
Yeah, but again, it's all when it comes to now, this is what we did in Z460 was different. We try to put focus on safety, so maintenance for safety. So we have these protective devices that we're relying on, right? And if they don't operate at all, or if they operate slower than we would predict, as far as incident energy, the incident energy will go up. So that's a difference between Z463 and 70B. As in Z463 for Canada, we explicitly said we want the priority to be on safety, then reliability and criticality of service. But, you know, the old adage is, you know, if you do more maintenance, you're going to have, you know, better reliability and probably a lower likelihood of occurrence of you know, fault conditions, right? So, and then the other thing I'm going to throw out there is some companies would have insurance implications that they also have to consider, right? So it's not only safety and risk, but some insurance issues would also be another reason why you should take a closer look at the frequency. So, and you know, annual, every 2 years, 3 years, 5 years, like these are decisions that aren't regulated, that companies have to make based on, again, reliability, safety, insurance, risk-based decisions.
The reason why I asked that, tell you, is I was at a few customer locations and I heard like they didn't exercise their breakers in last 15 years. I think it's pretty common. You come across this. So you don't know.
Yeah, but when you say that, believe it or not, molded case circuit breakers, the best maintenance you can do is exercising them. But guess what? No one does, right? Exactly. Because one, you got to shut off the power, right? Yeah. So there, you just said it, 724 or whatever, we can't turn off the power. You have to find the time where some of this maintenance, like exercising, requires that the power is turned off for, you know, minutes, not necessarily half an hour, but so again, does anybody exercise their molded case circuit breakers? I bring this up when I'm out there working with clients and they go, what? You know, so something as simple as that. You got to be able to turn the power off. You got to find a time when you can do it.
Thanks, Terry. So the next question is for Terry again. Is there a time frame for checking absence of voltage instrumentation before and after each test? I think they're talking about the live test for NFPA 70E or Z462. in Article 120.5.
Again, when you say time frame, like the time, it doesn't make any sense. If you're going to test a conductor and circuit part for absence, you're going to do it before you make bare hand contact. So you're going to test your test instrument, test before touch, at that point in time, right? Then you've truly established an electrically safe work condition, right? Maintain that electrically safe work condition when you're not wearing any PP and doing, de-energized repair alteration work. So you're going to test your test instrument on a known source. You're going to test it on the target conductors and circuit parts to establish 0 voltage, and then retest your test instrument to make sure it was functioning, right? And at that point, as long as you follow the other requirements of establishing electrically safe work condition, you should be able to take your PP off and do, the de-energized repair and alteration of components that you found that failed, right? So again, I'm just trying to read these questions and sort of provide an answer, as we all are, that sort of, really that's what the practice or procedure or policy would be if you're applying 70E or Z462. So this is a component of establishing electrically safe work condition, and you're going to do it right before you do any bare hand contact with exposed conductors and circuit parts, and maintain that electrically safe work condition, and then re-energize the systems after you're done your de-energized repair and alteration or your work.
Any comments, John?
I think he's covered it well. There's nothing more I really need to add there.
I've got after looking at the question again, I'm wondering if somebody was thinking, all right, we an hour earlier we did the live dead live test, and now do I have to test? I'm going to get into another cabinet. I'm going to get into another piece of equipment. Do I have to test the voltage, the test instrument again? And the answer is yes. You're testing the test instrument right before you're testing for the absence of voltage. You're testing for the absence of voltage phase to phase and phase to ground of each conductor and circuit part. Then you're testing the test instrument again. And even right after you do that, 20 minutes later, you go to another piece of equipment, you go through the same steps every single time. You don't, oh, I've tested my test instrument once today, I don't need to do that again. Yes, you do.
Sure. Thanks, Charlie. So let's go to the next question. I think this is for Charlie again. So what is your opinion on knockouts in the panel board for installation? Is it better to have some or none at all?
I have no opinion on this. There are panel boards out that have, and what they're talking about is the stamped knockouts, where maybe you have 1/2 inch and then 3/4, 1 inch in the pieces of equipment. That's fine. What someone has to be extremely careful of and is, all right, you've got a panel board that's out there mounted, it's energized, it's in the field. The electricians in the plant have been told to go in and add some more circuits into that panel board. Well, we have to be careful about what we're doing there. And I have known of some electricians that have gone in, some maintenance people that have gone in and drilled holes in the panel board. They've added their own knockouts. They put in conduit, they've run wire with the equipment energized. Extremely dangerous. That is a violation of electrical safety in every way. So there are things that we can do. We do it on a shift when it's shut down. Do it. There's other things, completely block off and have it where there is no exposed energized electrical conductor circuit parts or whatever has to be done, but don't just drill a hole in there. And I'm an electrician by trade. I went through the electrical apprenticeship program. I was either taught the wrong way of doing things or I was not taught the right way. What did we used to do? If we were drilling a hole in the top of a panel, we would put a piece of cardboard under it, right? So that the metal shavings wouldn't fall on live energized electrical conductors or circuit parts. All of that's a violation now. I mean, cardboard isn't an acceptable method of blocking off and keeping everything electrically safe. So we have a document 70E that we can go by, that we can be electrically safe by complying with the provisions in that document.
Thanks, Charlie. Only comment I have is basically, so if you have a knockout and if you're using it, just punch those. Or if you have something that's you punched and unused, just put a plug or something so that you protect it from the external rodents and such to enter into the panel, okay? So I've seen situations where the electrician is doing this work and then he's just punching that knockout and he's not using that conduit and just leaving it open. I think that's a bigger mistake, I would think so. So the next question is for John. So what are some of the key reasons not to sign energized work permit? I mean, this is a very interesting topic. Energized work permit, I think John can handle this.
Sure, I'll be happy to talk about it. Well, basically, let's talk about when you might need an energized permit. One would be if you're purposefully making rubber glove contact with energized parts, which shouldn't happen very often. If you're doing work beyond diagnostic work, is also considered permit work. In other words, if you are doing, the regulations acknowledge you got to have an energized reference point to do troubleshooting. So while you're in the troubleshooting mode, they allow you to have a reference point that you'd be taking volt readings, for example, to figure out if you have a blown fuse or whatever. At the point when you've diagnosed the problem and you realize you have a blown fuse, you're supposed to lock out tagout at that point. If you do lock out at that point, you're not doing energized work anymore and you didn't need a permit. If you continue to work beyond diagnostic work, then you would need to pull a permit after you figured out what's wrong. And the third reason you might need a permit is if you're doing work inside of the restricted approach boundary other than diagnostic work. And so the reason you wouldn't sign the permit is if any of those things weren't true. The other thing is there's two components to the permit. There's a management piece. So management has to acknowledge that they know you're going to do this and they approve of it. Then a qualified worker has to do the testing in part 2 of the permit to figure out if it's safe to operate. And then thirdly, management then has to take responsibility and sign off that they approve the work, as I said earlier. So you would not want to sign the permit if any of those things, the reason for the permit, are not true.
Sure. Thanks, John. I think also NFPA 70 clearly states that economic loss or production pressures cannot be considered as a reason to do the energized work, right? Unless otherwise there is de-energization causes an additional hazard. And so that's the reason we can justify, but I think it would be difficult for most facilities other than life support facilities like the hospitals and other premises to do that, I guess so.
Anu, can I just comment that I think some people forget that in 70 and Z462, there are some exemptions where you don't need the permit, right? So
right, yes.
What I find is that everybody, or not everybody, but quite a few people, I'd say, they believe they need an energized electrical work permit for every energized electrical work task. So that's not true. There are exemptions documented in 70 and Z462. And really the reason for the exemptions it's because it's infeasible to do it de-energized due to equipment design, right? So there are valid reasons when the energized electrical work permit should be exempted and is not required. So I just want to make sure I add that comment that, it is not required for all energized electrical work tasks.
Correct. No, absolutely correct. Thanks for bringing that up. Absolutely. So the next question is for Terry. How does troubleshooting rate as required arc flash?
Well, some of these questions tend to blend together here as we get into them, but so this one, energized diagnostics and troubleshooting will require an arc flash risk assessment to be completed, right? So discrete work tasks under diagnostics and troubleshooting, voltage measurement, require both a shock and arc flash risk assessment to be completed. So the quick answer is, know what your work task description is, use the tools in 70E and Z462, again, table 135.c and 70E, and table 2 and Z462. If the work task is listed, condition of maintenance, the likelihood of occurrence of an arcing fault and arc flash is yes or no. So diagnostics and troubleshooting will require arc flash and shock PP, but beyond that, you also have to look at the voltage of the electrical equipment and can we sustain an arcing fault and create an arc flash. So we have the two sort of starting points in 70E, and this is another change between Z462 and 70E, is that 30 volts is the starting threshold in Z462 for Canada, and it's 50 volts for NFPA 70E. So then you have to look at the work task. Then you have to look at what the maximum voltage of exposure is, and if an arcing fault and arc flash can be sustained above those low end thresholds. and then decide if you need arc flash PP, doing an arc flash risk assessment.
Thanks, Terry. I think the next question is for John. So define safety as an integral part of a continuous process. So John, I want you to answer this based on a few things here. So one is basically you have a safety program that's set in place, and then what are the typical checkpoints or the stages within that safety program or within the journey when there is a changes made to the equipment or the worker qualification changes, or if there is a task that's not being performed over a period of time, and how does it really impact this continuous process? Can you just brief on that, please?
Well, I'll try. Normally, when we think of a continuous industrial or integral part of a continuous process, I think they're talking about processes where the shutting it down would not be possible in cases, for example, the typical example they use is like a polymer plant. If you shut down the equipment, the polymer would harden in the molds and destroy the equipment. Normally, OSHA doesn't recognize loss of revenue as being a reason to do energized work, but there are some processes that they indicate are so supercritical processes such that shutting it off really isn't feasible. You still have to come up with an equivalent system though, and so with the OSHA regulations, if you're not going to go by the numbers and have something shut off, you got to come up with an equivalent system, and that's what the permitting process that we talked about earlier and all that are supposed to do. And then the rest of your question was what, Banu, I think?
So this other question is basically what in case if the person has not performed the task over a period of time and he has been assigned to do it like after 6 months or 1 year since he has not done this. So how do you integrate that in your continuous?
Well, okay, there's a 12-month retraining requirement in there that if you haven't done a task within the last consecutive 12 months, you have to self-disqualify. Now, if you find yourself where you've kind of lost that currency, if you will, you simply have to get that currency back by working under the direct supervision of somebody who is qualified to do that task, and then basically we sign off on them again on that process. So there is what the FAA would call a currency requirement. In other words, you have to have done the test within the last 12 months. Your supervisor, by the way, under OSHA is supposed to never assign you to work for which you're not well qualified to do this. So they are supposed to know what your qualifications are as well. So they shouldn't normally assign you to do that. But the two checks in the system are the supervisor shouldn't assign you to work you're not current on doing, and you're supposed to know that yourself and self-disqualify. Those are the two catch-alls inside that parameter. Does that answer your question?
Sure, absolutely. And also other thing is the modification to the equipment, right? If there is any changes made to the equipment, that also requires retraining, correct?
If it's a substantial change, yeah, they're not cutting hairs here. They're talking about, the difference between AC and DC, analog and digital, that kind of thing. We're not splitting the difference between an ABB and a Siemens breaker that effectively work the same.
Sure. Okay. Thanks, John. So the next question is for Terry. It's what is acceptable proof that a person is qualified? Something signed, a signed piece of document?
So I've got to go backwards first, that if we talk about qualified person and specific to electrical work in Canada and US, we do have, the journey person electrician trade and training. Now, training is different between Canada and US. So the qualification training should be provided to become a journeyman electrician, right? You become an apprentice, you work with a journeyman, right? Again, I know depending on the state in the US, that's not necessarily defined, right? So, but in Canada, every province and territory, a German electrician is a certified trade, right? So there is training in technical institutes across Canada, and there's a 4-year apprentice program. So we can then get this qualified person as a German electrician that's defined to do electrical work. I want to note that there's other trades too that can have limited scope, a low voltage electrical work qualification training in a technical institute, and also perform energized electrical work. So that qualification training in Canada and US should be some basic industry accepted training to become a journeyman electrician or another task qualified worker that can do energized troubleshooting and diagnostics downstream of a local disconnect when it's this task qualified worker. Now, as far as who determines the qualification, well, the employer is going to hire this person to perform this job, this qualified person, and then would in turn look to the individual for this minimum qualification training. So they have, a training certificate, a ticket, let's call it the ticket in the pocket, right? So you should not be performing energized electrical work unless you have a suitable trade designation of training and you're ticketed, right? So you have proof of that qualification training when I hire you. And then after that, though, we've got to talk about competency, and there's not enough time to talk about competency. So qualification training would be some, certified training out there from some, designated association in the Canada, US, for, again, a journeyman electrician or these other task qualified workers, HVAC, overhead door and crane mechanic, a cathodic protection technician, fire alarm tech. These are some of the other task qualified trades. So again, acceptable proof is the employer has to say, oh, what's your background? What's your training? Do you have certificate from an institute? Like I said, in some of the states, and I know that, I think Texas as an example, an employer can hire an individual and inside the fence train them to be an electrician. So on the job training, in that case, the employer 100% qualifies the person with on the job training. But if that worker leaves that employer, they're not authorized in Texas to do journeyman electrician work. So again, this issue of qualification, that's up to the employer ultimately to decide what qualification training they're looking for. And for a journeyman electrician, it should be a certified, licensed, journeyman electrician that has some institutional training and apprenticeship industry experience.
All right, let's go to the next slide. So this is for Charlie. What are the prominent changes to the 70E, Charlie, that's upcoming standards, because you represent the 70E technical committee? I mean, if you can just give a quick top 3 changes you're looking at in the 70E 2021 edition, just please shoot.
Well, the new upcoming 70E is going to be the 2021 edition. It's going to be out about a year from now, a little bit less than a year from now. I was thinking about this, Bono, you said quick, but see, the question didn't say anything about quick. And I was going to tell Terry and John that I have the webinar from here just to cover this one question, but Bono, maybe we can do this on another webinar at another time closer to September of 2020 next year. But anyway, let's talk about a few of the changes here. The good news is there are not nearly the numbers of changes in the 2021 edition as there has been in every edition since the 70E first came out. This is probably the least amount of changes, and they're not really big changes anywhere. Well, there's a new article in the back of 70E. Article 360 is a brand new article, and it's safety related requirements for capacitors. The scope of that article 360.1, the scope says the article covers electrical safety related requirements for practical safeguard of employees while working with capacitors that present an electrical hazard. There's also a new informative annex, Annex R, that goes along with that is titled Working with Capacitors. Some of the things, there's in 120.5, and verifying and establishing an electrically safe work condition, in the 120.57, it talks about it tells us to use an adequately rated portable test instrument. Now, the portable was added in the 2018 edition of 70, so that's not new, but use an adequately rated portable test instrument to test each phase conductor and circuit part. And it used to say to verify it is de-energized, but now it's going to say to test each conductor and circuit part and test it for the absence of voltage. Now, this term is out there, it's being used, and some of us wanted some additional language in this one particular section that would say that it's okay to be able to test for the absence of voltage outside of the equipment. There's a company that makes an incredible device called a safe test point. And this incredible device is mounted on outside of equipment, and it's tied into the line side of the equipment. And so when the equipment is de-energized, instead of opening up the cabinet to go into and test for the absence of voltage, which of course we're going to have to be suited up for both shock and arc flash, this can be done from outside of the equipment without wearing PPE. You can test your tester from the outside. You can test for the absence of voltage and using this safe test point, then test your tester again. Once you've done that, you've verified the absence of voltage, and then you can open the door without wearing shock or arc rated PPE or flash PPE. So this device is an incredible device, and the wording wasn't added in there, but there was some information that the committee wrote saying, well, there's nothing that's keeping you from using that. It's okay to use that, which was okay. I wanted something stronger because I wanted companies and qualified persons to know there are other options out there besides opening up the equipment and have to be totally suited up in testing for the absence of voltage. There was a change in table 130.5. You remember in 130.5, there's at the end of all the tasks, it talks about normal operation of equipment. Well, that text that was in there, it sort of looked like a task, but it wasn't a task. So that text is taken out of that table of 130.5C. And there's a footnote that's added, and the footnote's going to say equipment is considered to be in normal operating condition if all of the conditions in 110.4D are satisfied. It's saying the same thing, but it's just taken out of that table. One of the things that was, and this will be the last one I'll talk about here, and we'll save the rest for another webinar. 130. Talking about outer layers, and this is in section 130.7C9B, talking about outer layers. In the section right now, it says garments worn as outer layers over arc rated clothing such as jackets, high visibility apparel, or rainwear shall also be made from arc rated material. That's in there now. What I have always been teaching was that outer layer had to be equal to or greater than the potential incident energy. Well, this is a change to me. I heard some of the other instructors saying, oh yeah, I've been teaching it this way all along. Well, I haven't. The note, the information that's going to be added is going to say the arc rating of the outer layer worn over arc rated clothing as protection from the elements, or for other safety purposes, such as a high-vis vest, and that not used as part of the layered system shall not be required to be equal to or greater than the estimated incident energy exposure. Now, this is going to show up also in table 130.5G and in table 130.7C15A or C15C for PPE. When it's talking about high vis clothing or the outerwear has to be arc rated, but does not have to be equal to or greater than the potential incident energy. And I feel like this is big. And other companies, I talked to a couple of companies after this, and the gentleman from Bulwark mentioned, which Terry, I know you know him well, he mentioned that, oh yeah, this is, they've been going by this procedure or policy all the way along. For example, in a clean room, the suits, they call them bunny suits. These suits, a worker may be working on something that has a category 2 or maybe 6 or 7 calories of incident energy, where the bunny suit only has a category protection of maybe 4 calories per centimeter squared. So it's some places known about this, but I think this is, to me, this is pretty big. This And I know companies like Bulwark sell high-vis vest, both in a mesh style and also in a heavy-duty style that I think they've got a vest for 25 calories. Of course, your arms aren't protected, but I had always thought, well, that outer layer also has to be equal to or greater, but it does not. So that for me, that was a big change, and that's going to be in the 2021 edition.
Thanks, Shel. I think, as Charlie mentioned, this is a huge topic by itself and a separate webinar itself. So definitely stay tuned next year. Maybe in September, we'll call Charlie to do that 70E changes webinar. And as far as the product which Charlie endorsed, the safest point, Grace makes a product. And if you want to know more information on that, those are in the handout section within that webinar console. You can just go and look at it. So let's move to the next question. This is for this to me. What are the current trends that OSHA is looking at or writing violations on? I think I can answer this question based on my research with the Department of Labor and Bureau of Labor Statistics. So recently I looked at some of the violations or some of based on injury facts data from the BOL. So most of the violations or citations are around 1910.147, which is a lockout, tagout, control of hazardous energy, which still stays on the top 5. And also the second one is the same one, which is 1910, 331 through 335, subpart K or S. I can't recall. This is on the electrical requirements. So that's again one of the major violations. And interestingly, also came to know that there was a huge jump in the special employee category that's mentioned as helpers in electricians, where the injury rates have significantly jumped by about 77%. So we're doing an ebook based on this criteria, which will be releasing it next month or so. Just look for the information, which will have more details on those citations as well. So with that, we'll go to the next question. This is for Terry. Can retraining requirements be met using online courses, or do they require classroom time? Terry, I would like you to answer this, Terry.
So this one's been a controversial discussion for a long time. Just as a note, I do attend the NFPA 70E Tech Committee meetings as a guest, and I am a voting member of the CSA Z462 technical committee. I've been on Z462 since the beginning, and just as a note on this particular question, it's come up at the meetings. So when Charlie mentioned some potential changes to 70E, and I'm not sure if this one's, because I think it's in second draft, that the training article in 70E may, I'm not saying it will be, but it may add in computer-based training or e-learning as an option, right? So that said, we have to remember that 70E and Z462 are standards. They're not adopted into law. They're industry accepted standards. So in occupational health and safety in North America, right, e-learning or computer-based training, whatever you want to call it, is widely used for occupational health and safety training across the board, right? So I don't know how we would say that you can't have electrical safety training delivered in an e-learning platform when all other safety training is available in e-learning. So it comes down to the employer deciding what methods of training they want to deploy and when they deploy it. So the employer could have instructor-led training. The employer could have e-learning if they so choose to, right? And they could have blended training, a combination of e-learning and instructor-led training, right? So at the end of the day, right now, 70E does not, and Z462 do not include and identify e-learning or computer-based training, right? But as I've said to many clients, it doesn't matter what the standard says. It matters what you as the employer will use as demonstrating due diligence. The hierarchy of risk control methods, training is one of them. If you can provide e-learning for refresher or instructor-led training or blended between the two, that's at the employer's discretion, in my opinion. Now, there is an old OSHA letter dated about 20 or 25 years ago. But 20 or 25 years ago, e-learning wasn't what it is today, right? It was automated PowerPoints that slid across the screen, right? Well, now e-learning has evolved, deploying adult learning strategies that are phenomenal. The graphics are gaming quality, they're interactive. You can really make, in some cases, you can make e-learning more effective than instructor-led. So again, pre-training requirements met by online training, it's up to the employer to decide ultimately right? Instructor-led is the most common arc flash and shock training, but there are e-learning courses available out there for arc flash and shock that are excellent. But again, it's due diligence. The employer has to decide what they want to do. Even instructor-led training, all instructor-led training is not the same, right? So it's a matter of the employer deciding what training they want to use, how frequently they want to provide that training, and to meet their due diligence requirements.
Thank you, Terry.
Just to toss one other thing in there from the OSHA side, and that is under OSHA, there's in many cases, not all cases, there's a requirement for what they call demonstrated proficiency, which means you have to translate that head knowledge to your hands. So I think it's perfectly, I agree with Terry that it's very possible to use online learning for the cognitive part of the discussion. But some things like lockout, tagout, or grounding, for example, would normally require you to demonstrate proficiency as well. So the e-learning may very well be part of the overall process. It may not be in and of itself enough if there's a requirement for hands-on demonstrated proficiency, and that's just under OSHA.
If I can just make one more comment, the training is knowledge transfer, and John alluded to what I call competency validation, right? So it's knowledge transfer. Competency validation is a whole other topic, right? Which, as you know, we could talk about that for a while. So qualification training, knowledge transfer of, in this case, NFPA 70E or CSA Z462 requirements are one thing, but really you got to then apply that knowledge and apply it correctly to get the benefit, which is to get the risk reduction that we want to achieve, right? Which is eliminate the exposure or reduce the risk by applying the knowledge. And ultimately, another question is probably going to come up about electrical safety programs. If there's no policies and practices, it doesn't matter what training you provide. The workers come back from the training and they don't even know what they're supposed to do with the information, right? So training can be delivered, e-learning, instructor-led, a blended approach. It's the employer's decision.
Thanks, Terry. Thanks, John. So the next question is for both Terry and Charlie. So what levels of trade and safety training does a qualified electrical worker need? I think you covered this on your previous answer, Terry. I think if you want to just add a few things to that, Charlie and Terry, please.
Well, I think the last question and the previous questions we did answer this. So, you know, qualification training, in my opinion, should be provided by an approved, you know, institution, whether it's a college in Canada or the US, or the electrical joint training centers from the IBW. This qualification training as a journal electrician or other task qualified workers, that would be the best way to get that training to your employee. Or if you want to work in that trade, that's the best place to go to get that training, so it'll be accepted by industry, right? Safety, electrical safety training, arc flash and shock is a separate issue. One thing that I'll comment is the training for apprentices in Canada has inadequate content on arc flash and shock. I have attempted to get the curriculum to be updated, but it gets way political with the provincial advisory committees that develop the training content or curriculum for apprentices. So I'm really concerned that that's where we're lacking, you know, instructor-led training is for the apprentice electricians. In Canada, and specifically Alberta, where I reside, what happened is they did the arc flash and shock training in the 4th year because the first year apprentice doesn't do energized electrical work. I'm going, what? Right? You know, how do you train an apprentice if you don't give them a test instrument and show them how to use it on electrical equipment starting in the 1st year? Not day one, but eventually you're going to get this 1st year apprentice. He's going to work with you. You're going to show him how to do energized work. So that's the other challenge, is the arc flash and shock training content. It will not be adequate, most likely, in the trade qualification training for apprentices and other task qualified workers. So in my opinion, it does have to be provided separately by the employer when that worker arrives on site. They should provide extra or separate arc flash and shock training to 70 years Z462, because the training in the institution will not be adequate.
Thanks, Terry. So go to the next question. This is for John. I think it's a long question. So in an electrical panel with a 480 volts incoming feeder to a breaker, if incoming feeder conductors are guarded from possible contact by a worker, would the arc flash incident energy be calculated on the primary or secondary side of the breaker? John, please go ahead, John.
Yeah, no, this is a loaded one as well. There's a few things to consider. From the engineering side, there's two schools of thought when you're modeling panels with a source or a main breaker in the panel. One school of thought is to assume that the main breaker would actually be able to clear lower side faults on the load side of that breaker, and it would not fail catastrophically and produce an arc flash of any kind. the benefit of that approach is that the label on the panel will be lower incident, considerably lower incident energy than if you did what they're suggesting here. If I calculated the incident energy on the source side of that breaker, in particular, if that breaker is connected directly to a transformer, from the load side of a transformer to the first main breaker almost always has a lot of incident energy there. The main breaker will usually lower that to a much lower level. So one school of thought is to be extra cautious. We call it ignoring the main using the software, and we say, look, we're going to assume that if a fault happens in that panel anywhere, there's going to be enough ozone produced to make a conductive cloud, which may involve the source of that breaker. You would label that. That would protect you, so you'd never underprotect your people, but you'd also have tons of incident energy in many cases, so you wouldn't be able to do as much work. So there's really not a right or wrong answer with that. That's an engineering call as to whether or not you're going to include the main or not when you do those calculations. The other part of the discussion is about guarding and whether or not you have what we call effective isolation. Recognizing from an arc flash standpoint, if you have like a pad mount transformer has this ability, if you open up the right side of the transformer, the left side of the transformer is the high voltage side, that's bolted shut with a steel door rated for the same as the door that you're opening. If you have effective isolation, you can assume that the other part of the system is not going to become involved. In truth, we've done investigations and forensic investigation where we melted steel, right? The arc lasted long enough to burn a hole in the enclosure and still had enough residual energy to kill somebody on the other side. So when you talk about guarding, especially if you're talking about Lexan shields and things like that, be very, very thoughtful if you're going to trust it to actually absorb an arc flash event. Because if the arc flash event lasts longer than expected, you could very easily have it'll breach the enclosure and still hurt somebody on the other side. So there's quite a bit going on here from the engineering side and also from the practical safety side.
Thank you, John. So the next question, I will take it. So this is how to apply safety to manufacture electrical panels to control conveyors. So I think the first thing comes into mind is this industry standards, which is the UL 508A for industrial control panels, and also there is NFPA 79, which provides the guidance on building the industrial control machinery. And the two things I would like to highlight here is when it comes to the control panels, it's a totally different animal because it poses multiple voltages. So the quick things from the product standpoint, what we do is we have the programming ports or the grace ports where you provide this engineering controls through the door, so you don't need to open the panel. The reason why you mentioned this, specifically the conveyor systems and other control type of panels, is primarily because the technician or the person who is optimizing these conveyor systems may not be a qualified electrical worker, but still he will just take that quick minute to just open the panel, understanding that I'll not be touching this 480 volts or 600 volt system. I'm just accessing the PLC, which is basically inadvertent contact. Suppose if he gets accidentally in touch with that energized work. So just make sure that this person uses some safety by design control so he doesn't need to open the panel, which the products we provide to solve some of those needs. And the second thing is the disconnect. If you have a sequester type disconnect switch that's provided outside the panel where you have the complete isolation to the power circuit, yes, it's easy for you to open the panel and perform the work. I mean, in summary, I think I can say definitely think of these safety by design features as you design these control panels, specifically that has both the power and control components. Okay, so any other comments you'd like to add, Terry or John? Because you guys see this a lot as well.
No, I don't have anything to add to that.
No, I have nothing.
Thank you. Let's go to the next one. This is for Terry. Can a finger safe components be considered safe when performing a risk analysis for working near energized circuit parts? Terry.
So again, when we look at 70 and Z462, they're work task-based standards. So we've got to start with what the work task is. What am I going to do? Am I going to go into some electrical equipment? Am I going to open the hinge door? Am I going to remove a bolt on cover? There's other issues we've been talking about with respect to the Energized electric work permit, but let's neglect those. We want to specifically look at shock risk assessment. All right. So I've got some job that's assigned to me. I have to go into this electrical equipment. I should, as the qualified person, know what that electrical equipment is. This gets down to experience and knowledge and competency. So I know, and I should know what's on the other side. So now we get to what's on the other side. Is there adequate finger safe guarding and insulation on the other side, right? So again, I'm doing my shock risk assessment and I should know. And if I don't know, then I need to find out. And again, there's a couple of different pathways here in this workflow. But finger safe components, right? We should trust that they are going to be safe, that you can't make inadvertent movement into those components, right? But you have to be careful because not all electrical equipment will have 100% finger safe guarding or insulated conductors and circuit parts, right? So again, this is a question of the qualified person understanding what equipment they're going to be going into Energized, right? And what's on the other side of the door or on the other side of the cover. And if there is finger safe guarding and insulation, and it's completely such that there's no inadvertent movement risk, then there's really no shock risk. But that's a separate consideration from the arcing fault and arc flash exposure, which still might be interaction, as it is interaction based, right? So you see these questions are, unfortunately, one answer is not necessarily the complete answer, right? So you have to do an arc flash risk assessment and a shock risk assessment. And if it's completely insulated with finger safe guarding, right, or insulated conductor circuit parts, you still may have an arcing fault and arc flash risk related to the work task. So yes, if there's adequate insulation guarding and finger safe, you've eliminated the inadvertent movement risk into those conductors, right? And you should not receive a shock, as long as, this is another point, the condition of the finger safe guarding and insulation is still, right, good, right? So again, it's a subjective decision, but the qualified person will need to make these decisions, right? So finger safe guarding and insulation, inadvertent movement risk, you can't get shocked, as long as, again, the condition of those elements of the electrical equipment are in a normal condition.
Okay, thanks, Terry. So the next question is for John. So when will the US enforce the requirements for listing and labeling of equipment sold in the US? John.
Well, first of all, the U.S. won't be probably the enforcing agency. The enforcement of this, if you call it that, is going to be more indirect. Normally, the code is enforced by the authority having jurisdiction, which is typically a state electrical inspector or something like that. The idea of listing and labeling establishes what we call suitability. So the code will say that whatever equipment we install or use has to be suitably applied so that it's working within how it was designed to be used. The evidence of suitability is that you have listing and labeling. So it's kind of an indirect way to get there. In terms of enforcement, OSHA would enforce this mainly if you had some sort of an accident and in the investigation, the equipment was not listed, for example, that would be a much weaker position to be in than if you're using all equipment that has been tested and found that it's safe to use. And there would also be the possibility of legal actions outside of the work if you're using equipment that isn't properly listed. So the enforcement, the impetus for doing it is mostly either from OSHA citations relative to suitability and application, or possibly legal issues, which I'm not qualified to talk about. If you're using equipment, if you killed somebody with equipment that wasn't listed, that would be another count against you, so to speak.
Thanks, John. So the next question is for Terry. What is the best way to conduct an arc flash assessment for a mobile generator powered location that moves several times a year? How different that could be?
So again, it's very interesting how these questions move around and whatnot. So if you have a mobile generator powered location, so if that's a fixed system, so it's the same generator, right, moving from location to location, your source of fault current hasn't changed. Now the challenge will be the temporary power, because I'm assuming this is temporary power generation, so temporary power distribution generation. The length of your conductors to your panel boards will change, right? So again, I was thinking about this one a little bit, and again, what I've discussed at times is if you have a fixed generator as far as size, but your cable lengths could vary, you could do two things. You could do an instant energy analysis study for this system, and then you could look at the cable lengths and have a lookup table for cable lengths to the sub-distribution, and then have instant energy calculated at sub-distribution. That said, again, depending on the size, if it's a single generator or if it's a large industrial construction site, then it starts to get pretty complicated, right? So if you did do an instant energy analysis study for a fixed generator, the issue would be, cable lengths, just, thinking out loud, to any sub-distribution off that generator. But if it's multiple generators, right, that's another topic as well. Ultimately, we have to recognize there's two methods to determine additional protective measures when you do an arc flash risk assessment. and the arc flash PP category table method could be used as well. So again, you've got two choices: inter-energy analysis with some challenges because of potentially the cable lengths to sub-distribution, as long as the generator doesn't change, right? Again, I'm just trying to answer this one with, an understanding that it would be temporary power for construction, probably, with basically the power is going to be distributed off the panel boards for portable cord and plug connected electrical equipment, lighting, and anything else that's fed off of this generator. So I'll open up to Charlie and John maybe to offer some comments as well here.
Go ahead, Charlie.
No, that is a wide open question. I think Terry did a great job of some explanation of that. I think that everything is correct what he said.
So if you guys need more clarification on that, probably need to hire one of these guys to have a consultation. Because some of these things can be explained in detail because of the time constraints and such, because those are application specific, and it'll be a detailed conversation. So you guys can reach out to them after the webinar and you can go through that. So let's go to the next question. This is for Charlie. If a 2000 amps frame breaker has a 1600 amp trip, do I have to meet the 2000 amp current requirement with the incoming cables? Simple question.
All right, let me, when we were giving these questions, Banu helped give them out, and he did not give me the question about using online courses. And probably the reason was because my answer would have been, no, you cannot use an online course. You have to use one of these 4 instructors that are doing the webinar right now. Banu, Terry, John, or myself. One of us 4 have to do your electrical safety 70E arc flash training. See, that would have been my answer a while ago. So that's why Banu didn't give me that one.
Sorry.
which is okay. But I'm actually hired by some of these online courses to update and correct. I've got one right now that they sent me some questions that the questions are pretty bad, and just they were getting a lot of complaints from people saying this question and answer is not correct. So they're hiring me to go through and look at those questions and revise them or update them or throw them out and give them new questions. So I have things to do with the online courses, but not as much as I have to do with teaching live electrical safety seminars. All right, back to the question that I was given here. If a 2000 amp frame breaker has a 16 amp trip, and now I'm assuming it is an adjustable trip circuit breaker. It could be a modular type with a specific module installed, but let's look at what the National Electrical Code says. The NEC in Article 240, which is overcurrent protection, 240.6, A talks about standard size fuses and circuit breakers, which is now, there's now a table 240.6A that gives us standard size fuses and circuit breakers, of which we know most of these in that list. We know almost all of them, but let's look at B and C. We use, a lot of times these sections are overlooked. Well, B talks about adjustable trip circuit breaker. And B says the rating of the adjustable trip circuit breakers having external means for adjustment. So if it's a modular type that a component is put in the side or the back after it's been pulled out, this wouldn't apply. But if it has an external means for adjusting the current setting, long time pickup setting, not meeting the requirements of 240.6C, it shall be the maximum setting possible. Therefore, if this question about the 2000 amp frame breaker, it meets B and not C, then the conductors installed would have to be rated up to 2000 amps. All right, so what does C say? C is titled Restricted Access Adjustable Trip Circuit Breakers. And this section says a circuit breaker that has restricted access to the adjusting means shall be permitted or can have an ampere rating that is equal to the adjusted current setting, long time pickup setting. And it goes on to say restricted access shall be defined as located behind one of the following. And there's three that it gives us. Removable and sealable cover over the adjustment means, bolted equipment enclosure doors, or locked doors that are only accessible to qualified persons. So if this frame breaker is in an electrical equipment room and the electrical equipment room is in a room that is behind locked doors, and this room is only accessible to qualified persons, then the breaker, the conductors coming out of that would only have to be rated 16 amps and not 2000. So 240.6 B and C is where you want to look for the information for this this answer.
I'd like to toss one other thing in there too, just from the engineering side, is that we have to size the conductors not only for the thermal damage limits, but also withstand as well. So short circuit current and clearing time need to be taken into account as well. So it may be that you have larger conductors just because of the clearing time or the withstand rating is what I'm getting at. So that's the other side of the equation. I agree with everything Charlie said. I just thought I'd toss that in there about the other reason we engineer the conductor sizing.
Thanks, John. Thanks, Charlie. Let's go to the next slide. So this is for Terry. Is it acceptable to model the electrical safety program on NFPA 70E but not follow every recommendation? Customizing the standard.
So this is something that I'm very passionate about, is electrical safety programs. If people know me, this is where I focus a lot of my attention. So again, an electrical safety program and the framework or the table of contents should be based on occupational health and safety management system standards. And then in this case, for arc flash and shock, we look to NFPA 70E or CSA Z462 as a standard to use to apply policies and practice requirements that we document in our electrical safety program. So it's interesting because the question doesn't say, well, what requirements do you not want to apply? So really, when you look at 70 and Z462, they're standards, so they're pretty prescriptive. So what I recommend is that you ensure that your electrical safety program documents the policies and practices with respect to the prescriptive requirements of 70E as a basis of due diligence to OSHA, or in Canada, OH&S regulations. So your electrical safety program, and there is specific content in 70E and Z462 advising you that your electrical safety program should have this information in it. So I would say that you need to make sure that that prescriptive content that 70E and Z462 require are in your electrical safety program. We mentioned a few things like, the Energized electrical work permit, right? So that's a mandatory requirement. Some companies say, well, we're doing what, Z462 or 70 tells, but we haven't fully implemented the permit yet, right? So your electrical safety program really is the document that your company should develop and put into place as the go-to document. Underneath it are the requirements of NFPA 70E and Z462, and then you've trained your workers on the generic requirements of 70 and Z462, and then those workers come back and they're required under policy to then utilize the requirements of 70 and Z462 as dictated by your electrical safety program. So again, I could talk for hours on this topic. I think there you go. Yes, use 70E. There's prescriptive requirements. Make sure those prescriptive requirements are deployed through your electrical safety program.
Thanks, Terry. So the next question is this for John. Do you have any recommendations how to manage the risk of complacency amongst electrical maintenance staff? This is a good question.
Yeah, it's a very involved question too. But yes, complacency is a management system problem, and so as such, management will be required to manage it. And the kinds of things we do to avoid complacency, it has a lot to do with the culture of your organization, and that's established, as I said, by the management systems in place. So who you hire, who you fire, who you promote, how management manages the safety process, if it's a value of the organization versus an obligation, or if you're following just because of rules and regulations, or if it's a core value of the company. These things have to do with the kind of culture that you cultivate in an organization, and safety culture is a couple of days of training if you want to get through that. So it's way too involved for this discussion, but it is a management problem to manage. And when you manage the best in class company, safety is seamless. the work and safety can't be differentiated from each other. They're just inherently integrated together. And it's obvious from the first line supervisor on up to the CEO. It's an integral value of the company. So it's a management problem that needs to be managed, and it's cultural and it's focused. Having said that, I'm an old foreman as well, and each crew has its own little culture, a little subculture there. So if you're in a company that doesn't have a tremendous safety culture, if you will, your crew can be the best one in the whole company. So I encourage people not to think that it's only programmatic; it's also localized, and so that's my little journeyman's pitch. I'll shut up now.
Thanks, John. I think it's a pretty loaded question. So next one is, I have heard the term before, is bonded the same as grounded? If not, what's the difference? So sorry for the typos. Charlie, this is for you because it lies on NFPA or NEC. So.
All right. So, and I think all of us have mentioned this before. Each and every one of these questions could be a discussion that takes 2 hours or more. And our viewers have written some incredible questions, and we could go on and on. Grounding and bonding, Article 250 in the National Electrical Code. This is an article that could easily take. I could talk about this in a one-day seminar. Years ago, I was asked to be a guest speaker at Purdue University for a couple of engineering classes. And when the woman, the professor contacted me, she said, okay, you have an hour and a half. Can you, and I said, what subject? She said, Article 220, branch circuits, feeder, and service load calculations. And I was doing a series through Electrical Contractor magazine that took about 4 years to go through. And that was at least 3 pages every month in the magazine. And she's saying, okay, yeah, you've got an hour and a half. I want you to cover Article 220. About 2 weeks before the class, she called me up and said, oh, by the way, can you cover Article 250, grounding and bonding? And I thought, oh yeah, I've got plenty of time left over from Article 220 that in the rest of that hour or hour and a half, I can also cover Article 250. No, of course I could not cover that. Where this information, they are not the same terms. Bonded or bonding and is defined in Article 100 of NFPA 70. Now, NFPA 70 is what we know of as the National Electrical Code. Bonded is defined as connected to establish electrical continuity and conductivity, and that's what bonded is. It's to establish electrical continuity and conductivity. Well, what is just the term ground? Years ago, it was a very long defined term, and a couple of editions back, it was simplified. Now ground is simply defined as the earth. Well, what is grounded? Well, in Article 100, grounded or grounding is defined as connected or connecting to ground or to a conductive body that extends the ground connection. And it would take a lot more detail of giving you examples of bonded and grounded, just it depends on what you're talking about, whether something has to be whether the NEC says it has to be grounded or bonded. So it's, at least I can give you some references to start looking up some material out of Article 250 in the code for requirements pertaining to grounding and bonding, but the definitions that pertain to grounding and bonding are in Article 100 of the NEC.
Thanks, Charlie. I think Charlie is telling just go and buy the NEC or NFPA 70 so you can read and interpret that, and then if you have more questions, reach out to him, right, Charlie?
Yes.
Good. I mean, it's difficult to just answer all this in a deep depth. So next question is for Terry. What is the likelihood of OSHA accepting a valid risk assessment showing that an accident wasn't likely in accident response?
So again, as we've been discussing, these questions are interesting, right? So I'm going to frame this in an OH&S officer or an OSHA officer. So if you have an electrical safety program and it includes the risk assessment procedure required in NFPA 70 or Z462, and you've followed up and have demonstrated that you've, again, and when I talk about risk assessment and the risk assessment procedure, that would where the employer, I recommend committee-based risk assessments for work tasks, and we use that tool to define the hierarchy of risk control methods that we want to apply to reduce risk, right? So if we've gone through with that risk assessment, we've identified that the inherent risk level was not acceptable. We applied the hierarchy of risk control methods to achieve a residual risk level that was as low as reasonably practical. And in turn, then the qualified person that's exposed to arc flash and shock, right, has applied all those expected risk control methods, and we have documentation to prove it, then I think when the incident investigation occurs, the due diligence of the employer has been demonstrated to be adequate using a risk assessment process to define the hierarchy of risk control methods. So I think that that's what I'm going to try and answer that question, that risk assessment is valid, would be totally respected, right? And it would be evidence of due diligence. And then the incident investigation would vet out, what was the root cause of the worker, still potentially getting injured, right? But if the worker identified the arc flash and shock PP, right, then the potential injury or damage to health has been managed, and the likelihood of occurrence should have also been managed, right? So the due diligence should be good, and OSHA should respect that risk assessment as brought forward as evidence of the employer's due diligence.
Okay. Thanks, Charlie. Sorry, Terry. Terry, your webcam is off. Do you mind checking the webcam if you don't mind? I'll go to the next question. So this is for Charlie and Terry. So where do you see the PPE for electrical safety changing in the next 5 years to help assist with bulking PPE while troubleshooting?
Well, again, worker acceptance, and John talked about culture, and behavior, and briefly, like this is an ongoing challenge as well. It's bulky, it's uncomfortable, it's too hot, right? Well, what we've seen in the last 5 years, if not 10 years, is that the arc flash suits and the multi-layered systems, the total system arc rating of these arc flash suits and the improvements in the fabric is that they're ultra lightweight now. So if this is coming from a company that still has, a 10-year-old arc flash suit, they were bulky, they were very thick, they were a lot less comfortable for the worker to wear. So I'd advise the person that asked this question to do some research. There's multiple vendors now that have ultra lightweight arc flash suits that are not bulky. So again, not only the PP itself, but even the lens technology for the arc flash rated face shields and hoods too has improved. But again, worker acceptance, I think, will always be a challenge. You are going to, if you're in Texas and it's 105 out and you're wearing an arc flash suit, you're going to sweat. And then what you have to do as the employer is you have to advise the worker that they're going to have to take cool down periods. But at the end of the day too, how long are you wearing this arc flash suit? You should only be putting it on right before you use it. Wear it for the 5 or 10 minutes that you need it and take it off. If you need to wear this arc flash PP for a longer time period, then take cool down breaks, right? But I don't know why you would have these suits on for 15 minutes, a half an hour. It doesn't make a lot of sense. Maybe you're having difficulties doing the troubleshooting and diagnostic work, but then you take cool down breaks. So again, it's not bulky anymore. The latest arc flash suits are unbelievably comfortable. The multi-layer of fabric is very thin, the actual thickness. The quilting is no longer like it was in old arc flash suits. So there's my 2 cents on that one.
I agree with Terry that the arc rated clothing and gear has come an incredible, it's come incredibly far over the 5 years, 10, 20 years. The first arc flash arc rated shirt that I have is, I think it is 8.7 calories per square centimeter of incident energy protection, arc rated protection, ATPV. And it feels like I'm wearing starched burlap. It is just bulky, heavy, thick. The shirts they have now, even just the shirts it's a material that feels like cotton. The same type of 8.7 or 8.9 arc rating for a shirt is just, it is such a light, thin material. Again, it feels like cotton. And even what Terry mentioned, the arc flash suits. I've got a couple of jackets that I take around when I'm teaching my custom seminars that I come out to your plant and teach when you hire me, or one of these guys up here to come out and teach our incredibly live seminars. So I've got the jackets, and they're both 40 cal jackets, but it's like one of them is about twice as heavy as the other. And the clothing, the equipment, everything has come such a long ways. Where it's going to go in the next 5 years, I don't know, but if it keeps going like it is now, it will continue to get better from here on out. And it's of course it's a mindset, and of knowing that you have to wear arc rated clothing, shock and arc rated clothing and equipment in an energized or even a potential energized condition. If you are testing for the absence of voltage, if you don't have that safe test point that Grace makes, and you have to open the equipment, then you have to be suited up for shock and arc flash to test for the absence of voltage. So it's industries have come a long ways, but I still see industries and people that are just not up to date with not only the clothing, but also the training as well.
Thanks,
Just one
John.
last thing. Employers have to have a budget for updating, and looking at what's new, whether it's technology, PPE, right? You just don't spend money on it 5 years ago. So again, as far as the arc flash suits, they've accelerated in the last 5 years to be ultra lightweight. And by the way, people need to understand that there's an arc flash suit available with 140 calorie per centimeter squared arc thermal performance value out there. And this is what I call the 40 cal myth, that we don't have to stop work at 40 calories. The suits that are at a higher ATV are actually ultra lightweight as well. All right. So again, it's like a winter jacket these days would be a 140 cal arc flash suit jacket that's available in industry.
Thanks, Terry. I mean, Charlie made it sound like the arc flash PPE is going to be 5 years down the line, be more like a beach wear that you can wear it in the vacation time.
I don't know about that, but you'd have to check with Oberon or Bulwark or somebody to see where they're thinking this is going down the line.
Absolutely, they become very ultra-wide, as you said, right? So let's go to the next question. This is for Terry. So how do you address the human error element under 70E?
So again, when you do the risk assessment procedure in the 2018 edition of 70E and Z462, it uniquely identified human error as a key component of your risk assessment procedure. So again, this isn't really anything new with respect to workplace safety. If you look at incident investigations, human error would be at the top of the list in the root cause side. So I think this gets back to a question of, we have a qualified person, and then they have competency, right? And that's separate from human error. Then the employer really needs to have an HR department, and depending on the size of the company, that may be just the one owner and five electricians, but as the owner and the supervisor, you're the HR department. So human error has to be managed in real time, right? One, by the worker themselves. They have to be of good health and mindset, right? So that's both mental and physical health. That's the worker's responsibility to come to work and be prepared to work, but the employer does have an obligation to try and manage and monitor that. Very difficult on the mental health side of things. So the supervisor really has to have a good rapport and relationship with their workers, meet with them in the morning, talk with them on the phone, and have some gauge, right, if you can, but it's not perfect. So at the end of the day, the employer tries to manage this, the worker in real time before they do an actual energized electrical work task, because the risk assessed procedure with respect to like of occurrence would have one of the considerations that the worker is fit to do the work mentally and physically. So at the end of the day, I recommend the employer has documentation in place where right before the worker proceeds to do the energized work, the worker acknowledges that they are of good state of physical health and mind before they actually do the work, and the worker signs off on it. This is in the field where the supervisor isn't there. So again, loaded question. There's more to it than just simply saying, you know, you can't manage it. The employer can with some of what I just suggested.
Okay. Thanks, Terry. The next question is for me. This is product related of Grace. What we do here is the R3W LED lights, a real zero energy confirmation device. So this is more like you can see the information on our on the handout that's being provided. So as far as the LED indicators, this cannot be used for verifying absence of voltage. We try to tell this very clearly. So the LED indicators can be used only as part of a mechanical lockout tagout to visually verify the voltage presence only. So in simplistic terms, this is intended for the use of a task qualified person. In addition to the bump test, they can visually verify there is no energy present after they disconnect the switch. This does not mean measuring this, performing a 3-point test, which is with another product what we do, which is a safe test point, which Charlie mentioned. You can look for more information, or you can reach out to us if you want to learn more about this device. So with that, what's the next one? What is the least understood part of electrical safety? John, this is for you.
Well, in my opinion, it's not even close. It would be grounding and bonding. That's the most common thing I think people misunderstand. And the safety tip I usually give to workers is that I recommend they wear those low voltage gloves all the time when they're troubleshooting, even opening enclosures. There's a number of situations that occur where usually grounding and bonding issues where the frame of a device can become energized and stay that way. And so I think, in my opinion, it's grounding and bonding, and I would tip my hat to Terry and Charles to get your opinion as well.
Well, I guess that, you know, I talk about electrical safety as a trifecta. We've got safe installations, maintenance for safety, and then safe work practices. So again, what's the least understood part of electrical safety? That, in my opinion, all three of them work together. But again, as far as arc flash and shock, I still believe that people don't understand that training and buying PP is not adequate due diligence. There's maybe a comment. I sent the guys on training, I bought PP, I've got electrical safety taken care of. No, I've got to look at those three standards and make sure that I have documented policies and practices in place that manage these hazards through that document, right? So that's the least understood part. Don't have an adequate electrical safety program, just believe training in PP and getting studies and labels is adequate.
So I would like to add one point from my side. So when I look at it, we see as a worker qualification, because people always think, everyone thinks who has a screwdriver thinks that he's a qualified electrician. So that's one of the things I think it's big from our end. So go ahead, Sean.
One of the things that I see when teaching and talking with maintenance worker, electricians, even safety professionals, and I'll go into a plant and someone, it may be the electrical supervisor, says, oh, we don't do any live work. So in fact, some guy, I've heard this more than once. And until we have established and verified that the equipment is in an electrically safe work condition, it is live. It is considered live. So we have to be ready. We have to be suited up for shock and arc flash until we have established an electrically safe work condition, until we know that this equipment is electrically safe. And that's one of the things that I think a lot of people don't understand. Oh, I've turned off the power, and maybe even it's an external source into a cabinet. It has a disconnect on the outside, and someone says, oh yeah, I've turned the power off, it's dead on the inside, so I'm going to open it up, and without wearing any PPE, I'm going to go ahead and test for the absence of voltage. Well, no, until you've established that that piece of equipment is in an electrically safe work condition, which there are 7 or 8 steps in doing so, that piece of equipment is energized. And that's a big thing that a lot of people don't understand. They just don't, I don't think they get the concept of oh yeah, just by turning it off from the outside does not mean that it is de-energized on the inside.
Thanks, Charlie. I mean, I would like to also ask a poll question to the audience to see what do they think about this, right? So as far as challenge, biggest challenge, as they say it, here's the question. Do you guys see the poll question?
Yes.
Yeah.
Back to.
Closed. Let's see.
I tried voting and I couldn't. Then I saw on there that the panelists can't vote. So, oh well.
Let's see. I didn't see anything. So it's like nobody said anything. Nobody responded, so probably didn't show up on their screens. Okay, we're just trying out new things here. So let's go to the next one. So this is for Charlie. So what are the electrical safety requirements for different voltage panels, less than 60, 60 to 120, 120 to 480? I think this is a pretty elaborate question. Charlie, please.
Yes, like so many, this is a very loaded question. Well, we have to, like Terry's mentioned, do a risk assessment. What are we dealing with? Are the things that we have to look at are shock and arc flash. What is the shock? Well, shock is based on voltage. So if it is if it is, except for 120 volt, of course, if it's less than 50, it's going to be considered safe, or in Canada, less than 30, Terry mentioned, unless there are some other outlying circumstances or things that could be there. But if it's just 120 volt, then our shock boundaries, and this is from a footnote under the table 130.4 DA, if it's 120 volts or less, then it's avoid contact is the restricted approach boundary. If it's once we go above that, then we look for the limited approach boundary, whether it's fixed or movable. We look for the restricted approach boundary, and then we can determine what the shock boundary is. Well, then arc flash is another provision that we have to consider. We have to think about and look into what is the arc flash boundary. And so it's there's a lot as far as just coming out with an answer. Oh, you do this. If it's a 120 volt panel, if it's a 208 volt panel, you do this. If it's a 480 volt panel, you do this. We don't, it's not that cut and dry.
We'll get to as many questions as possible. So this is, for me, I'll be installing a P-S11S21 M3RX. This is a product related question. So this is a voltage test station, as you can see in one of the handouts, what we provided. So this is, you can use it for electrical lockout tagout, where it has a combination of voltage presence indicator and also a safe test point through which you can verify the absence of voltage from outside the door with a with a max fault current of about 2.35 milliamps, as I can recall. So look for that information on the product handout that we provided with the webinar. So the next one is for John. How best to manage electrical safety competency or authorization program? John.
Well, again, I think this has been partially covered by the other speakers that we talked about, but managing the electrical safety competency, again, is, well, it involves management functions in terms of how they manage the process, but it also includes the training process. And so the competency, typically, we follow the military model. We have vetted procedures, we train you on those procedures, we drill on those procedures, we test on those procedures, and we repeat. So we keep the competency up of the workers by that sort of activity. The management system also needs to be managing and evaluating the safety process to make sure it's functioning. So when we have managers out on the shop floor, OSHA believes that the manager will be observing the work at least once a day. Under OSHA, they call that regular supervision in the code. And what they're actually asking the management to do is not only be out there to manage human behavior, but also to verify or validate if the system is functional or not. So the management is an ongoing effort to assess the effectiveness of the safety process. And then the other side of the coin is the worker side, which is more relating to training and testing. That's my initial reaction to that.
Thanks, John. So the next question that came in online was, I don't know who can take this. Is racking out a starter from a live bus considered energized work? Simple as or no?
Well, yes.
Okay. Thanks, Terry. So I'm going to skip one question because of the time limitations. So this is for me. Can we use the R3W alone for a mechanical isolation, or do you need to test both to verify to comply with the 2012 OSHA letter? So again, the OSHA letter dates back 2012. Who has been asking this question? Basically, they don't tell that you can't use a voltage indicator. All they mention is basically you can't rely the device as a sole means for verifying absence. In simplistic terms, if you're using for mechanical isolation, you can use it with your bump test. In addition to that, you can use it for a visual voltage presence indication only, but this device cannot be used for an absence of voltage test, for which you need to use a different device. We call it a safe test point. Okay, so the next question is, how do we keep track of the electrical safety standards change happening in other regions? Terry.
Well, again, what other regions, right? So again, North America, we're harmonized between CSA Z462 and 70E. 70E has been adopted and is used in other countries globally. So if this person's looking for, globally, well, NFPA 70E is used in South America, it's used in Africa, it's used in the Middle East. It usually travels where US companies are active or other countries are considering this topic. 70E is used in Australia and New Zealand. Now, these different countries are potentially developing their own specific standards or documentation. So if your company has operations in different regions across the world, start with 70E, then find out what the region's doing with respect to its own standards, right? Europe as well. So again, it needs more research. You should do research, but if you take 70E with you wherever you go globally, it's a great place to start. Or Z462. Again, remember they're technically harmonized.
Okay, thanks, Terry. We've got a few more questions I can take. So the next question is for John or Terry. What is acceptable proof that a person is qualified? Is it something signed document, or what does that means?
John?
Well, you want me to answer first, Terry?
Go ahead, John.
Okay, acceptable proof typically it would involve using some sort of a training guide, which is usually a spreadsheet that lists the tasks that you must master to be qualified for various levels of functionality. And so each individual item is a signed off item that has to be signed by somebody who's qualified to evaluate their skill. And so normally a qualified electrical worker, the accomplishment of what we call journey level status is actually sign-offs by many other people who themselves are properly trained and evaluators as well. So we list all the tasks that somebody is supposed to be able to do, and then as they get signed off, they are fully qualified for that task. So there is a source document that's expected. You normally would be able to produce this with OSHA, and it typically takes the form of a spreadsheet that includes tasks, a signature, and a date when each step was completed. When the entire thing is signed off, then you are a fully qualified electrical worker, and then you would be assumed to be a journey level person for the task listed, not every single task. So you can be fully qualified for something and not qualified for something else, even though you're a journeyman. I'll stop there.
Thanks, John.
I'm just going to add that the supervisor is responsible for this under OSHA and OH&S regulations. So it's quite clear that the supervisor is responsible for ensuring that their workers are qualified for the work that they assign to them, the jobs and the specific work tasks. And on top of that, after that, that the supervisor is responsible for the competency of the worker. So if the supervisor carries responsibility here, and they need to understand that and realize that for qualifying their workers and deeming them competency for the jobs and the specific work tasks assigned to the worker.
Okay, thanks, Terry. So I'm going to pick the next questions because we have only a couple of more minutes. So what is the best way to handle assessments of contractors who can have multiple people at different times on their crews? John?
Well, there's several ways to evaluate them. You can look at the experience modification rates of the contractors themselves, their reputation. Normally, I recommend with our customers, if you can establish longer-term relationships with contractors and maintain them, that's a plus, rather than getting a brand new crew every time they show up, but that may not be possible. And then, but as I said, assessing they should be able to produce an electrical safety program. They should be able to produce evidence that their people have been trained properly, like the training guides we've discussed. They should have electrical operating practices and procedures for the various things they do. In other words, a formalized program, like Terry was alluding to earlier. And and then of course, as I said, ensuring that their people are properly trained. You should be able to be an OSHA compliance officer and say, prove to me that the people you're sending here are properly qualified, and they should be able to provide that documentation. And then of course, there's a whole legal side of it as to how you handle contractor safety. It's not part of today's discussion. I'll leave it at that for me.
Okay.
Great answer.
So are there arc flash calculators that provide rough estimates to assess on-site risks? Terry.
Well, I know over the years that I've looked at it, there are simple, spreadsheet calculators out there. Again, I think, people that procure those have to be careful and understand what they're buying. And if they do, what are the limitations? The Flowbone power system software, it's not cheap. Well, it's not cheap because it's very detailed and very comprehensive. So buyer beware when you procure any type of calculator. John, you may want to make a comment too.
Yes, I agree. On a good day with favorable winds, we know these calculations are a bit understated, and if you're roughing it in, I'm not really a fan of that because my biggest fear when I do engineering studies is if I make a mistake and I understate the incident energy and I set somebody up for failure, that would be devastating to me. And so I don't like roughing it in. We're already kind of roughing it in just for the way they currently are set up. We're getting better at it, but it's just take it with a grain of salt when you evaluate and interpret the results of the study.
With the new IEEE 1584, 2018 edition, also the formulas have changed. There's, in my opinion, a lot more complexity to, making sure you establish the right parameters before you run the calculation. So again, any of these available spreadsheets, I'm not sure if they could, handle, maybe the updated changes and requirements. Buyer beware on any spreadsheets. I'd recommend you stick to the detailed power system software where the packages available from North America have gone through all the checks and balances, and members of those organizations have been involved in IEEE 1584 and participated, and so just buyer beware.
Thanks, Terry. Again, I think we couldn't able to get through all the questions. We were able to get through about 50% of all the questions that's been asked with the time constraints. So I think you guys see the contact info on the screen, Charlie, right? So yeah, please reach out to the panelists if you have any questions specific about your electrical safety training or consulting or audit needs. I mean, these guys have 30+ years of experience in doing this, so they'll be your best go-to guys. And if you have any product-related questions, please definitely reach out to me. My email is there as well. Here, I'll just put this on screen. And as you exit the webinar, please do take the exit survey so that it gives some feedback to us on the content and how we can improve in the future. Okay. Thank you again, everyone. Thank you, our panelists, for taking your time and devoting for this event. Thank you so much. Bye.
Thanks, Manu. Thanks, Grace. Take care. Bye.
Thank you.
Thanks, Charlie.
Goodbye, guys. God bless.